Welcome back everybody. I won't waste your time. Today we have an integral from minus infinity to infinity of, all of this. The first thing I notice is it's an even function over a symmetric interval, so it's twice the integral from 0 to infinity. Now this numerator is sine x cos x all squared, which is half sine 2x all squared. That's just a double angle for sine. And now we have this half squared times 2, that would be a half in front, and we have this thing here. Okay, cool. The square of a trig function is a bit hard to deal with, so we'll just write it in terms of cos. This is half times 1 minus cos 2 times 2x using the double angle. So that will give us this integral here, 1 minus cos 4x on the numerator, and we should probably split this up into two integrals. Okay, then I'll probably call these like I1 and I2. So that would mean I is equal to I1 minus I2, and we'll deal with them separately. For I1, it looks promising to let x equal tan theta because we have an x squared plus 1. And yeah, so that would mean theta is inverse tan x. And then tan inverse infinity is basically approaching pi on 2. So the top bound will become pi on 2. And then we have a 1 over sec squared squared, right? Because tan squared plus 1 is sec squared. We also have a sec squared at the top because that's the derivative of tan. And so this will just become the integral of cos squared theta. We use King's rule because the bounds are 0 to something. That would give sine squared as the integrand. I have a video on this if you don't know what I just did there. Okay, now we have two forms of the same integral, so we can add them together and divide by 2 to get back the original integral. And that's good because when you add sine squared and cos squared, you just get 1. So yeah, we don't have to do any antiderivative work. The answer is just going to be pi on 16. Okay, that was clean if you ask me. For this other integral, I'm first going to do a substitution, letting u equal 4x, and you'll see why later. So this would mean x is u on 4, so dx is du on 4. So we'll have something like this. So we'll have a 1 on 16 at the front, and then cos u over u squared plus 16, all squared. But then this other 16, which was inside this whole square, that will go up to the numerator, right? So I guess we'll just have 16 in front of the integrand. I'm sorry, I have to do this, okay? I'm gonna quote a result. Don't click off. I'm sorry, I had to do it, okay? I'm not gonna bother proving this today. It's kind of a classic result. The integral of cos alpha x over 1 plus x squared is pi e to the minus alpha on 2. Now, you can prove this using contour integration. I don't know much about that. I think you can use Feynman's trick as well. Math 505 definitely has a video on this. I'll link it in the description, hopefully. But yeah, I'm not going to bother proving this. We don't got time for that. So we need to somehow massage this into the form that we have here. But how? Firstly, I'll let u equal to alpha x. That way we'll only have cos u at the top. So x is u over alpha. So we will have a alpha at the front, it looks like. Now, if you look back at what we are after, we just need a square in the denominator. But I mean, we can't just add this square here. We need to actually do it properly. The way to do that is by differentiating with respect to alpha. Because when you differentiate 1 over something, it becomes minus 1 over that thing squared, times the chain rule, I guess. So now let's differentiate both sides of this result. And on the left, you can take this derivative inside the integral as a partial derivative, which just means alpha is the variable, u is constant with respect to the differentiation. So this would be minus 1 over this thing squared times 2 alpha because of the chain rule, right? On the other side, I mean, we could do product rule, e to the minus alpha times the derivative of 1 on alpha, and then minus e to the minus alpha times 1 on alpha. Factoring out minus e to the minus alpha, and then I guess just cleaning this up into one fraction, we have something like this. We can cancel the negative signs from both sides and also divide by 2 alpha to give this, and we'll just clean it up a bit so we have this sort of expression. So we're basically done now. We just need to see what value of alpha we need to take. It's pretty obviously going to be 4 if we look back at the original integral. So taking alpha equal to 4, we have pi e to the minus 4 times 5 over 4 times 4 cubed. And I guess 16 is 4 squared, so we can maybe cancel these out like this. We'll just have a 1 on 16. So we have 5 pi e to the minus 4 on 16. Now, we remember I is equal to I1 minus I2, and I1 was pi on 16. So this is our result. Let me write the full integral again. integral minus infinity to infinity sine squared cos squared over x squared plus 1 all squared is equal to pi on 16, 1 minus 5 over e to the 4. Thank you everyone so much for watching. This was a pretty cool integral. I did quote a result, so I mean, it could have been better. I am planning on doing some linear algebra videos, so stay tuned for that. It shouldn't be too long, hopefully, although I haven't started. So